The next part of our lecture for soil water and permeability is the flow net. The flow net or flow nets is a graphical method for calculating the amount of water that can seep through the ground. Suppose here I have water that is up to this level, and I have a sheet pile wall here. Usually this sheet pile wall, I'm doing it to prevent water from seeping outside. But suppose the sheet pile wall was not long enough, so water managed to seep from the other side and it reached up till this level. So there is part of the pressure that was consumed. Why? Because I had here a pressure of say H1 and I have here a pressure of H2 which is less than H1. Where is this difference? The difference was consumed in pushing water to move from this point to this point. Suppose you don't have soil here. What will be the level of water here? Higher to which level?
To the level of the other.
To the level of the other. الأواني المستطرقة. If you have water in a tube and it is connected to another tube, sure the water will go to the same level, exactly the same level, because there is no friction. But if I put soil sample here, or not sample but soil here at this area, so the motion of water here consumes part of the pressure. So I can reach these two levels and it can stay there all of the time, because it's not a temporary case. No, it is a final case. The pressure was consumed in the motion from this point to this point. So now it is stable, because the actual pressure at this point is not like the actual pressure at this point. The actual pressure here is the same pressure here minus the pressure was consumed during the journey of the water. So we ended up here with losing some of the pressure. If I am designing a water storage system, then I need the pressure here to be zero, not to be any H1, H2. No, I want it to be zero. Why? Because if it is zero, it means that water will come from here, move up till here, and then it will stay in place, and I will have my water stored inside all of the time. How do we do the flow net? The flow net consists of two main objects, or two main things: the flow lines and something called the equipotential lines. What is flow line and what is equipotential line? The flow line, it just gives me the direction of the flow. The particle of water at this location will move till it reaches this location and go to the outside. The particle here will move also like this. Of course, there are many flow lines, millions of flow lines. But here I will only draw the flow lines that I need to calculate the quantity of water. There is some rules that you are going to know. These rules tell you which flow lines to draw, which equipotential line to draw, and based on the number of the flow lines and the number of equipotential line, we can calculate the amount of water. So now we know what is a flow line, and we said that there are millions of flow lines, but what you have is samples of these flow lines. What is an equipotential line? From the name equipotential, it means that potential means pressure. Potential, potential energy. So it is the equipotential energy line. It's the potential energy due to the pressure. So equi means the same. So I want a line where all the points at this line, on this line, have the same water pressure. How to do this? Study this line. What's the pressure of water on this line? Can anyone tell me what is the pressure of water on this line? Maximum, as we said, it's the maximum. It is the height of water. Because actually I did not start. This line is the starting point. I am starting with the full pressure of water. So it is also an equipotential line, because the point here, the pressure is this H. The point here, the pressure is H. The point here, the pressure is S. So it is an equipotential line. The last line is this one. It's called also an equipotential line, because what is the head of water here? It is this H. Here it is also this H. Here it is also. So this is my last. So I have the first and the last equipotential line. In between, there should be other lines equipotential, because water, when it moves according to these flow lines to reach the final flow line. Can you draw equipotential line? I have to give you some guidance how to draw the equipotential lines. This guidance say equipotential lines are perpendicular to flow lines. So this is the first thing you have to do. You cannot just here draw a line like this. Because if you draw a line like this, the angle between the line and the equipotential line are not 90 degrees. So you cannot draw it. So if I want to start, say from this point, I take a line that is perpendicular, connect it to another point where I have a perpendicular line, and here another perpendicular line, and I continue. And then I go to the other one and the other one. The relation always between the flow lines and the equipotential line is that they meet at right angles. I move to the next slide and continue my studying here. I'm trying to do this for a concrete dam. This is the amount of water. This is the difference in head. Here the head is very small, the amount of water is very small. This is the first flow line. This is the first equipotential line. This is the last equipotential line. These are equipotential lines in between. The angle between the equipotential and the flow lines are always not right angles. So these are important things. Now, if I tell you to draw, and I tell your friend to draw another drawing, everyone will choose his own flow lines, not one line, flow lines, and everyone will choose his own equipotential lines. But as we said, we are going to depend on what you draw to calculate things. So both of us should have the same values, or at least similar. Similar in the sense of, if I have number divided by number, then the answer should be similar. If I increase the number of flow lines, then the number of equipotential lines should be increased in the same manner, so that the relation between the equipotential and the flow lines are the same, whether I draw it, you draw it, he draw it, anyone can draw it. If you draw more equipotential line, then you will draw more flow lines, and so on, or vice versa. Still we are in an introduction. Let's just read. A flow net is a graphical representation of flow of water through soil mass. It is a curvilinear net It is linear but in the shape of curves, formed by the combination of flow lines and equipotential lines. Flow lines represent the path of flow which the water will seep through the soil. Equipotential lines are formed by connecting the points of equal total head. So what we added here is that they are equipotential in terms of total head, not in terms of any type of head. It means that the full pressure on it will be the same as at any place. If I have this is an equipotential line, it means that the total head here is like here, like here, like here, like here. Every point it's the same. Properties of flow nets. The angle of intersection between each line and the equipotential line must be 90 degrees, which means they should be orthogonal to each other. It means they are 90 degrees. Two flow lines or two equipotential lines can never cross each other. It means that I cannot have two lines moving and then suddenly I find them crossing each other. This will never happen because it's an equipotential line. How come in an equipotential line this have a head and this have another head? How come they will once be in the same point? It means that the head will be the same. No, each line cannot cross the other line. By the way, this is important because it will help you in understanding, and this is one of the important questions in the exam. In the exam, you will be asked to draw a flow net and to calculate so and so. So unless you understand how to draw, and you will not just draw, you understand, you have to draw it yourself. Once you finish this lecture and you want to understand 100%, then you have to draw by hand what we are just saying. So third thing, equal quantities of seepage occur in each flow channel. It means that a flow channel is the space between two flow lines. If I have here, let's take this one. This is a flow line and this is a flow line. You have to understand that between this flow line and this flow line, there is here a flow channel. If I want to draw, suppose that I started with drawing this flow line, it means that this is a flow channel. This area is a flow channel. If I want to draw the next one, I have to draw it so that the amount of water that is passing here is equivalent to the amount of water that is passing here in this other channel. So it's not open for me to draw any flow line. I should draw flow lines so that I can sense that the amount of water passing within this channel are the same in everyone. So I may draw, suppose that you draw your first flow line here. So in this case, you will have to draw your second one here. But suppose I draw the first one here. I made it smaller. So my channels are now smaller. So my next one will not be here. It will be earlier. So you may draw something, you may draw another thing, but if we abide to all these rules, though we have different shapes, but we will get the final answer similar to each other. So equal quantity of seepage occur in each channel. Head loss is the same between two adjacent potential lines. If this line, I expect that it means that here, imagine that this is zero. Imagine that I have here the head is zero. I don't have water here. And here I have H. So at this point, I have h. And at this line, I have 0. Suppose h is 6. The height here is 6. So if I draw this one and I measure the pressure of water here, and I find that the pressure here was reduced from 6 to 5, then the next potential line should be at 4. And the next potential line should be at 3, and the next potential line should be at 2, and so on till I reach the 0 potential line, which will be here, because we said we don't have water here. So this is another thing that abides me not to draw any line. If I started, I have the luxury to choose my first flow line and my first equipotential line. But once I draw the first one, then the next one should depend on what I have sketched. So head loss is the same between two adjacent potential lines. Flow nuts are drawn based on the boundary condition only. They are independent of the permeability of soil and the head causing flow. This is a very important parameter. If I am drawing here the flow lines, I should draw it regardless of the type of soil. To draw this, I don't have to tell you that this is sand or this is clay. You can draw it without knowing the type of soil. You can draw it without knowing the head of water. If just a drawing, you don't know the value of the head of water, you can draw it. What happened is that each one of these equipotential line will represent a reduction in the percentage of the head. If here I have h, then here I have 0.9h, here I have 0.8h, 0.7h, I don't have values. So it means that these flow lines depends on the shape of my structure. It does not depend on the type of soil and the head of water. The space formed between two flow lines and two equipotential lines is called the flow field, in which it should be in a square form. I will keep this because I have to show it on a drawing. Either flow lines or equipotential line are smooth drawn curves. Okay, let's go to this one. What do they mean by that? They mean your drawing should be smooth. You cannot just start with this line and suddenly you have a sharp edge. No, you don't have sharp edge. Everything in your drawing should be smooth. The lines should be very smooth. This is the first thing. Also, if you look at this, you see this square or this boundary, this area between two flow lines and two equipotential lines. Put in your mind that you can draw a circle inside them. The circle will be tangent to the four lines. Look at these four lines. If I start with this middle point and this middle point and this middle point and this middle point, I can put a circle in this space. So in my drawing, I should always keep in mind, when I try, suppose that you draw this one and you want to draw the other one, keep in mind, if you take it here, you will never draw it to a circle, you will draw an oval. So the circle will always tell you the distance where to put your next equipotential line. So the first thing you should do is to start with the flow lines. Start by putting any flow line. I will put this one. And then I keep in mind that the next one should carry the same amount of water. Usually they tell me something keep in mind, take this distance. This is the narrow area. This is the thickness of the first equipotential line. The next one, you should make it a little bit bigger. The next one should not be here. It should be more than that, because it should a little bit bigger. Say between you and me, if this is 4 millimeter, the next one make it 6 millimeters, the next one make it 8 millimeters, and so on. This will give you a good shape for the flow lines. Then start drawing the equipotential line. Put your first equipotential line so that you can put a circle here, and you can put a circle here. But of course, when you come to the edges, you will have edge problems. Try to put a circle here, is impossible. Try to put a circle here, impossible. But at least try to put a circle here. Yes, it is okay. Try to put a circle here, it is okay. Here, okay, and so on. So, but ignore the edges. This is between you and me. At the edges, it is very difficult to adjust. But try at least your middle portion is working correct. Okay. Identify boundary conditions. What are my boundary conditions? By the way, we set the boundary condition while we were discussing now. We said that our first equipotential line is here. What is my first equipotential line? It's the start. It's the surface line where on top of me is water only. I don't have soil. So this is my first equipotential line. My last equipotential line is the exit line, the end of the soil. Whether I have water or I don't have water, it's not important. But if I have water, it will be always less than the amount of water in the first place. Sheet pile, where the molecules cannot cross the sheet pile, it means that it moves upstream and downstream. If I have here a structure, either it is a sheet pile wall, or it may be something like this. Something like this. It's a concrete. What will happen is that my first flow line, can you concentrate on this? My first flow line here, where is my first flow line? This is a flow line, but my first flow line is the first one touching my structure. So if I go here and here and here, this is my first flow line, because water will just pass next to my structure. In this case, if I have a sheet pile wall, then water will go from point A to point B, then to point C, and so this is my first flow line. Impermeable surface is the end line. This gives you your last flow line. So my first flow line is the one touching the structure, and my last flow line is the impermeable layer. In between, I should draw the flow lines and my flow net as a whole. Flow net is useful to determine the following parameters. It gives me the rate of seepage loss, the seepage pressure, the uplift pressure, check the possibility of piping, exit gradient. By the way, exit gradient means the pressure of water leaving the soil. Is it zero? As we said that we should do this in case we are designing storage structure, or it is just I'm studying a case of water flowing, so there will be an exit gradient. This is how we draw the flow net. By the way, this photo I will have to put it again because it was distorted. The photo was stretched down. So it is not the correct shape. When it is stretched down, then I cannot draw circles. So in the lecture that I will post for you, I will adjust the aspect ratio of the photo, because in this type of photo, the aspect ratio should be very much adjusted. It's not a normal photo. This is my structure. I have water from this side. I don't have water at the other side. I will start by putting the things that I know. I want to put the first and last equipotential line and the first and last flow line. Can you help me in this? Where is the first flow line?
And the structure.
Yes, below the structure. So it is from this point to this point. This is my first line. My last line.
Below the last impermeable point.
Yes, the touching the impermeable layer. This is my flow line. Then this is the flow lines. What about the equipotential line? Where is the first equipotential line? This one. And this one is the last equipotential line. So by chance, by coincidence, this full line is divided into three parts. From here to here, this is the first equipotential line. From here to here, this is the first flow line. From here to here, this is the last equipotential line. But this is by coincidence for this drawing. If my structure was penetrating the soil a little bit, it would be different. But just things that you should notice, that's all. Okay, I will start first by doing one thing. I will start by drawing this line. This is the first line that you should draw. What is this line? It's the first line to draw, not the first flow line. The first flow line is there. So from this first flow line, you draw, you put your first channel, the first channel where water is going to pass. It will be bounded by two equipotential lines. This equipotential line, which is the first one, and the one that I have just sketched. Let's look at our equipotential. This is the first one. As I told you, if you take here the distance 1 centimeter, take the other one, the distance to be 1.2 centimeters, approximately. Take the other 1.4, 1.5 centimeter. But what about this? This is less than, maybe it is less than the first one. Not important now. Keep it like this. But what is important for me, I have now 3 flow channels. This is the first one, this is the second one, and this is the third one. And I have here a portion of a channel, but I don't know what it is. So let's leave it now. I have now 3 channels. So now I drew the first 3 flow lines. Let's draw the equipotential lines. I have here the first equipotential line. My second equipotential line should be here. I try to choose the location of this line so that I can put a circle in this location. If I manage to put a circle, then my choice for the line is okay. I have to take into many things in consideration. First thing is that these angles are right angles. Here right angles, here right angles, here right angles. They should be right angles. In the same time, I can draw a circle here. Okay, I draw this line. Of course, the end will be perpendicular to this line because this line is also a flow line. So it should, and this equipotential line should be perpendicular to this flow line. If I want to draw the next one, where I should take it, this will be very easy. Why? Because you have this line, you have this line, you have this line. It is this new line that you want to add. Draw a circle here in your mind. Just draw a circle here and draw another circle here, and then draw a line tangent to these circles, tangent to the circles and perpendicular to the flow lines. Then you get this one, and so on. The next one, next one, next one, till you reach the final shape. So when we finish drawing this, then we will have to count the number of flow lines and the number of flow channels and the number of equipotential drops that we have. You see here these numbers 1, 2, 3, 4, 5, 6, 7, 8. These 8 are what? These are the number of the drops of the equipotential of the pressure. Here the pressure was H, here the pressure was 0. So each line of this show you a drop of H by 8. Here at this line, sure, without any measurements, I will look here, I will say that at this location H turned to be 7 over 8H. Here it is 6 over 8H, and so on till I reach here 1 over 8H, and I end up with having 0H. So I measure these numbers 1, 2, 3, 4, 5, 6, 7, 8. And then I measure these channels. This is important to concentrate because, as I said before, I already have 3 channels. This is 1, 2, 3. But here, it is not a full channel. This is part of its channel. So when I come to measure the number of flow channels, I can use a percentage or a fraction. I will consider this, suppose that I have here, go to the section in the middle line. This is 1, this is also 1, this is also 1. So this, I may consider it maybe 0.4 of a channel. As you see, it is subjective. If I say 0.4 and you said 0.3, who can tell me that I'm correct or you are correct? Nobody. It's something depending on judgment. So that's why flow nets is not very accurate because it depends on my accuracy. It might not be very accurate, but it is very easy. It can give me numbers very, very, very quickly, but it is not that accurate, and it needs me to follow few rules so that when I do my trial and you do your trial, if I end up with a result of 7, you end up with a result of 8. But it's not very good that I end up with a result of 7 and you end up with a result of 14. There's something wrong. I may accept some differences due to accuracy, but I cannot accept double numbers or triple the number. This means that I did not follow the rules as I should. So this is, by the way, this flow net is based on Darcy's equation, because I will take Darcy's equation. Darcy's equation say Q equal K, which is the coefficient of permeability. Of course, I have the coefficient of permeability. I can take a sample of the soil and test it anyway and get the K of the soil. The A, which is the area of the soil where water is passing. I is the hydraulic gradient. I don't have the hydraulic gradient. This is what I'm trying to get out of this drawing. By this drawing, I can get the hydraulic gradient. So if I get the hydraulic gradient, I know the K, and I know the area, because the area is known. If you know this height, then multiplied by the thickness of your section, then you have the area of water passing. Say you are taking 1 meter, so that this height multiplied by 1 meter, this is your area. So you have the area, you have the K, either given in your example or any way you calculate it. So what I need is the I. So I need the I so that I can calculate the quantity of water that will be passing. This is just to show you what I was just saying, the relation between the flow lines and the equipotential lines. This is the relation. If you look here, you will find that it is very easy. If I put a circle here, it will be circle that is tangent to the 4 lines, very easy. If you manage to draw a drawing where most of your squares, of course they are not squares, but where most of your 4-sided figures, you can put a circle inside them, then your drawing is very accurate. If all your drawings include ellipses and something like this, it means that you are getting wrong numbers. What will happen is that there is something called NF and ND. What is NF? Yes, here. This is NF and ND. NF is the number of flow channels. In this drawing, if I look at this drawing, what is NF? This is 1 channel, this is 2 channel, this is 3 channel. If I consider this number 4, then it is 4. It's not portion of, because a relative, this is a channel and this is a channel, a full, 4 full channels. So this is NF. What is ND? ND is the number of drops you have in the potential lines, or the potential drops you have. So how many potential drops, as you said in this is 1, 2, 3, 4, 5, 8. So I have 8 potential drops. So from a drawing like this, I get ND, which is 8. I get here NF, which we said that it was about 3.4. So NF by ND is 3.4 divided by 8. So if for this example, NF by ND is 3.4 divided by 8. If I divide both together, they will give me the value of I. If I multiply it by K, which is given, or I can get it by experiment, and I multiply it by the area, I will get the quantity of water that is seeping below this structure. So this is how we use, this is how we transferred the Darcy's equation into this one. Q is K multiplied by H. H is the difference in height, multiplied by NF by ND. So it is a formula. They substituted something for something, and they ended up with this this value that we are going to use in our drawings. Of course, I'm doing this so that I can use it in very complicated examples. Suppose you have something like this. This is the normal, just head, and here 0, and this is the distance, and this is a normal thing. Suppose that you have something here. Usually we put a shear key, we call it a shear key, or sometimes it is a hydraulic key, because it also it prevents the structure from sliding, and at the same time it prevents water, not prevents, but hinders water from passing. Do you know why, if I put something like this, water will be affected? You remember that we said that our first flow line is the one touching the structure. So at the beginning, my first flow line was moving like this, directly to the other way. But if I put something like this, it means water will come here, from here, move like this, and find something stopping it in its direction. So it have to go down and then to go up again and then continue. So I am putting obstacles in the way of the water so that I increase the path where water needs to follow. So this is another way. How to draw the flow lines for something like this. This is important, by the way, to know that something like this, because you may have example or in the exam you may face something like this. It should not be always the easy, the straightforward. No, there may be something like this. How can I draw the equipotential line? In this case, my equipotential line, this is one equipotential, second, third, and this one comes from the shear key, or from this this line. Anyway, regardless, there are many approaches how to draw it. Start with the equipotential line, or start with the flow lines. Do whatever you do. Do full channels or part of channels, whatever you do. But finally, if you draw something and in the final project, final output is satisfying all my rules means that lines are perpendicular to each other, circles can be inserted inside, then your answer is correct, my answer is correct. But what will happen is that I may end up with having NF by ND, which is, as we said, the number of channels here, NF by ND. If we are both correct, and I have NF2 and you have NF4, but I have ND 10, then in your case ND will be 20. To get, if we are both correct, 100% correct, if we are both 100% correct, or at least near to each other, then our value for NF over ND will be the same. But you may have different NF and I have different NF. You have different ND and I have different ND. But NF by ND should be the same. It means that this drawing has only one correct value for NF by ND. If you are accurate, you will get it very accurate. If you are less accurate, you will get it less accurate. But it is only one number. You can reach it by different values for NF and different values for ND. This is clear. I think these are the main things of this lecture. The final output of this is that you are able to draw a flow net. Once, as you see, it's a very trivial thing in the exam. You just draw few lines, count few boxes, and then put the numbers in an equation, and you have the number. It's very, very easy. But if you get a number that is very wrong, then it will be considered wrong because you did not follow any of the rules or guidance for drawing. Thank you, and this ends up our lecture for soil, water, and permeability. Thank you very much.